Hey, alright, here we are, linear equations and slope. So, slope-intercept form, that's simply y equals mx plus b, m being the slope and b being a y-intercept. The slope equation, if you recall, from our lesson, slope is the right... Oh, never mind. Remember that's y2 minus y1 over x2 minus x1. Remember we said the change in x over the change in y, which came from the rise over the run. So not a big deal if we can remember the rise, and then the rise is the y values. So what are we going to do with that today? Here's what we're going to do today. We're going to actually write the equation of the line with the slope of negative 1/2 that goes through the point 8 and negative 1. So we want it to be in slope-intercept form when we get done. So that's how we're going to get started. We're going to plug in everything that we know. The slope, m, is negative 1/2. Negative 1/2 goes in for m. While I'm here, the x value is 8. I don't know what b is. That's what we have to find out. What's the y-intercept? And the y value is negative 1. So I have negative 1 equals negative 4 plus b. And if you remember from way back in your summer work, we're going to add 4 and add 4. So the b value itself is 3. Did we answer the question yet? No! The crowd says no. Alright, we want to write the equation of the line. Equation of the line. B equals 3 is not an equation of the lines. The equation of the line y equals, that slope was negative 1/2 x, and plus 3 is what we solved for. So that is what we're after today. Alright, let's try that again. So we want y equals mx plus b. So y is 5. M is 2, x is 1, plus b is what we don't know, so remember this is x and y. That's how we plugged everything in. So 5 equals 2 plus b, subtract that 2, subtract that 2, b equals 3, so y equals 2x plus 3. Remember I'm plugging in the slope and the y-intercept. That's how I get my final equation. Alright, now let's see, if we go through all of our work here, so maybe we got y equals mx plus b going on again. Y is 7, and we have negative 3 times 0 plus b. Well, we know 0 times anything is 0, so this will give us b equals 7. So y equals negative 3x plus 7. Wait a minute, we could have skipped out on all that work if I recognized that if I have a 0, this is the y-intercept. Okay, anytime they give me that, use that as a shortcut. Don't do so much work. Oh my.
Slope-intercept equations are relevant in the real world. Come on, I'll show you. Almost anywhere you go, you encounter situations where you deal with rates of constant increase or constant decrease. Any situation like this can be described with an equation written in slope-intercept form. For example, to go out to Calistoga and see the geyser, we'll have to rent a car. So it's here where our search for the slope-intercept form equation begins.
Hi, can I help you?
Yes, I'd like to rent a car for the day, please.
Okay. Is a mid-size car okay?
That's fine.
Okay, here's what I can offer you. A mid-size car, available at $32 a day. It does include 150 miles free. Any mile after that is 25 cents a mile.
So the starting amount for the car is $32. That includes the first 150 miles that I drive. Then, for every mile after that, it costs an extra 25 cents.
That's right.
See? This is a perfect situation to describe using an equation in the slope-intercept form. It has both of the ingredients that we need to naturally describe an equation in this form. We have a starting amount of $32 and a constant increase of 25 cents per mile. The starting amount is the y-intercept, b, and the constant increase is the slope, m. Therefore, the equation y equals 0.25x plus 32 describes the situation, where x is the number of miles driven over 150, and y is the total cost for the car rental. The slope-intercept form equation tells us that y, the total cost of renting the car, is equal to 25 cents for every mile driven over 150 miles, plus the starting amount of $32 for the car and the first 150 miles. Having an equation like this is useful to help you make estimates, or to figure out how much the car will cost depending on how many miles you drive. For example, I know that Calistoga is about 80 miles away, which makes it about 160 miles round trip. Plus my errands will add on another 20 or so miles, giving me an estimated total of about 180 miles for the day.
Alright, so one answer you want to have when you come into class is, if we're using y equals 0.25x, 25 cents a mile, plus $32 for the car to start, how much is a car going to be worth about to run our 180 miles for the day? Remember, we get 150 free, so have that answer when you come to class. Alright, here we go. Now we're going to use what we already know. We're going to find the slope. So let's use 1 minus negative 3. Okay, so we know that's going to become plus positive. So let's go ahead and finish the top. So that's 4. So 1 minus negative 3. So that means I have to start with 2. So I have 2 minus 5 gives me negative 3. So this is my slope. And I can't do anything about changing that. Maybe you don't like that so much, but that's okay. And now we're going to do what we did in the last 2 slides. And to pick one of these ordered pairs, I'll probably choose the one with all positives. So we're going to use y equals mx plus b. The y value is 1, equals negative 4/3, and x is 2. Oh my goodness. Plus b, it's all over 1. Alright, so remember when we multiply fractions, we're going to multiply straight across. So I have 1 equals negative 8 over 3 plus b. This is a negative number, so I need to add it to get it to the other side. So let's go ahead and add that thing over. So add 8/3 plus, don't need that, so plus b, to clean that up. Alright, and the other thing that I'm going to do is add 8/3. But this looks a little bit funny, so let's say that this is 1 plus 2 and 2/3. Okay, so that's going to give us 3 and 2/3, which is b. So we can say y equals 4 over negative 3x plus 3 and 2/3. That's our final equation. Even though we had to deal with fractions, we can get through this. Alright, now if they give us some tricky things here, if they tell me x-intercept of negative 3, well if the x-intercept is negative 3, the y value must be 0. And if the y-intercept is 5, y is 5, and x must be 0. So now I have 2 ordered pairs. So if I want to find the slope first, so first thing is to find the slope. So if I start with 5 minus 0, and then I'm going to start with 0 minus negative 3. So we've got plus positive going on here. I got 5 over 3, that's the slope. And if you remember, they're giving me a y-intercept right here. So I can go right to the equation, y equals 5/3 x plus the y-intercept is 5, and we're done with that one. So use what you know. X-intercept means y is 0, y-intercept means x is 0, and if they give me a y-intercept, I already know what b is right away. So use your noggin when you can.
Linear functions can be used in just about every field, such as science, engineering, business, government, and communication, and in specific applications such as the trajectory of a descending plane, the construction of an access ramp, and the Celsius-Fahrenheit conversion formula.